Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss Gauss's law or Gauss theorem and when do we apply that Gauss's law. Let's begin. Statement of that Gauss law. The law states that the total electric flux through a closed surface enclosing a charge q is equal to 1 by epsilon naught times the amount of charge enclosed within that surface, where epsilon naught is the permittivity of free space. Permittivity is that factor. With the help of that permittivity, we can easily guess how exactly the medium play that role, the force of attraction or repulsion between the charges, that can be determined with the help of that permittivity factor. So, here mathematically we can write it, the total flux through that of closed surface, when that closed surface is enclosed by that amount of charge q, the total flux. Previously we discussed the expression for total flux, that is closed surface integration, let the surface be S, E dot ds, according to that statement, that is q divided by epsilon naught times of that of charge enclosed, q divided by epsilon naught. Here E is the electric field intensity, ds vector, that is the area vector, and epsilon naught, that is the permittivity of free space. Let us prove that Gauss law. To prove that Gauss law, let we consider a closed surface S. Here be the closed surface S enclosing the charge q amount of charge is enclosed within that closed surface S. Let ds is the area of small area element of that of surface S, small area element of that of surface S be the ds, that is ds. Here is ds, which is at a distance r from that of charge, that ds is at a distance small r from that of charge q. Let the electric field intensity at the area element due to the charge q is E vector, and that is the electric field intensity E here, and the area vector ds. Let the angle between the electric field intensity and the area vector is equal to, let theta, and the angle subtended, the solid angle of that of ds, means the angle subtended by the ds at the charge q. Let we take that solid angle, that angle, let that is d omega, the solid angle subtended by that small area ds at the charge q. Now we have to calculate the electric flux. First we calculate the electric flux passing through that of area element ds, then integrating we have to find out the total electric flux. Yeah, electric flux passing through the area element is, let d phi is equal to E dot ds, electric field intensity, area vector ds. Then the total flux, then the total flux through whole of surface S, that is closed surface integration over d phi is equal to, that is closed surface integration E dot ds, and the total flux phi is equal to closed surface integration E dot ds, that is E ds cos theta, E ds cos theta, where theta be the angle between E and ds. Theta is the angle between E vector, electric field intensity, and the area vector ds. Now the electric field intensity, that is the electric field intensity or the area element due to the charge q is E. E is the electric field, this is the magnitude of electric field intensity, at the area element due to charge q, and mathematically it can be written as 1 by 4 pi epsilon naught charge q divided by distance with r, square of the distance r square, that is the value of E. Now that value is putted here, so we have phi is equal to closed surface integration over S, in place of E we substitute, that is 1 by 4 pi epsilon naught q divided by r square ds cos theta, or phi is equal to q divided by 4 pi epsilon naught, these are the constant terms to that of outside, then close surface integration over S, we have ds cos theta divided by r square. That quantity ds cos theta divided by r square from the concept of solid angle. The expression for solid angle d sigma solid angle is equal to d sigma, and that value is equal to ds cos theta divided by r square, means the solid angle made by that area element ds on the charge q, that is the solid angle made by area element ds on charge q is ds cos theta divided by r square. That is from the concept of solid angle. Now instead of that quantity we substitute d sigma or d omega phi is equal to q by 4 pi epsilon naught closed curve integration over s, that is d sigma. The total solid angle will be how much? That is 4 pi, as closed curve integration over s d omega is equal to 4 pi, or phi is equal to q divided by 4 pi epsilon naught into 4 pi cancel out, so phi is equal to q divided by epsilon naught. That can be proved. This proves the Gauss law. Q be the total charge enclosed within that of surface S, and epsilon naught is the permittivity of free space. According to the statement of that of Gauss law, the total electric flux enclosing within that of closed surface charge q is the 1 by epsilon naught times of the charge enclosed, magnitude of charge enclosed, that is phi is equal to q by epsilon naught. Now that Gauss law can be written in the terms of electric flux density, as we know. Hence phi, that is total flux, closed surface integration over E dot ds, that is the phi flux according to the Gauss law, that is q by epsilon naught, or epsilon naught is multiplied here, so epsilon naught times of the closed curve integration over s E dot ds is equal to q. Now q within that of integration, so closed curve integration over s epsilon naught E vector dot ds vector is equal to q. That term epsilon naught into E, that is d vector, electric flux density. So closed curve integration over s d vector into ds vector is equal to q, where d vector is equal to electric flux density. Now this is the proof of Gauss law, but question arises, what's the importance of that Gauss law, means when do we apply Gauss law? Although that Gauss law is always true, but it is not always useful. That's the reason the ability to evaluate that particular integral, double integration, means the surface closed surface integration of E dot ds, is determined the usefulness of that of Gauss law. For this we construct a closed imaginary surface which is known as the Gaussian surface, near the charge distribution over which the magnitude of electric field and the angle between E vector and a normal to the surface have constant value. Here E ds cos theta means E cos theta can be taken outside the integral sign, and the double surface integration over ds is easily evaluated, means E ds cos theta. So, E cos theta treated as constant. Here that integral can be termed as why or when do we apply that Gauss law. Look at that particular equation, closed curve integration over S E dot ds, means that expression will be closed curve integration over S E ds cos theta. Since E cos theta is constant, that term will be outside, E cos theta to that of outside, double surface integration over ds. Now ds can be easily evaluated by taking E cos theta as constant to outside. Now the magnitude of E vector is constant for which case? For uniformly charged distribution. E is constant for uniformly charged distribution. Uniformly charged distribution. And the angle between E and ds, that is theta. Theta is constant for which case? For symmetrical charge distribution. For symmetrical charge distribution, E is constant for uniformly charged distribution and theta is constant for symmetrical charge distribution, and also for symmetrical surface. Also for symmetrical surface. That's the basic reason. By taking these possible cases into considerations, we apply Gauss law. Means the necessary conditions for applying Gauss law. Condition number 1, that is uniformly symmetrical charge distribution. That is uniformly symmetrical charge distribution. Here we can apply Gauss law. Again, another important aspects, that will be symmetrical Gaussian surface. That will be symmetrical Gaussian surface. Gaussian surface. By taking these two into considerations, we can apply Gauss law. And as far as symmetry is concerned, there are three kinds of symmetry. There are three kinds of symmetry. One is spherical symmetry. Spherical symmetry. Second one is the cylindrical symmetry. Cylindrical symmetry. And third one, the plane symmetry. Plane symmetry. These are the three kinds of symmetry we found out. These are the basic things. As these things are there, at that particular case, we can apply Gauss law. We apply Gauss law. So, with the help of this video lecture, we understand what is Gauss law or Gauss theorem. This is the statement of that Gauss law, and we prove that Gauss law in terms of electric flux density, and finally discuss when do we apply that Gauss law. The basic 2 points on which we can apply Gauss law. So, with this useful and informative notes, let me wind up this session. Thank you.